Alright, here we are troubleshooting the RF circuitry. As you can see, we're trying to nail down a sensitivity problem. As all systems integrations go, you usually have a few minor difficulties. So we'll see how it goes. N8ZRY, checking 1, 2, test 1, 2. Test 1. Alright, now we're working on the ironing out some transmitters first. So if we send a CW tone 6 meters, 10 megahertz per division, we see that we have some nasty low frequency tones that are maybe 40, 35, 36 dB down. They should be 60s or more. Interestingly enough, the current 6 meter low pass filter is fairly lossy. We get about 105 watts out without the filter in line. With the filter in line, we get 75. So there's a couple issues to work out. Alright, so the radio is now complete. And I'll show you the front panel here. This is the line voltage in, main power, manual transmit indicator, tune, tuning knob, function button, single sideband CW. That's your headphones. This is the telegraph key. This is the microphone, antenna, function indicator, volume control, microphone gain, AGC, and this switch is for the signal meter / transmit power meter. So down is signal RF voltage at 50 ohms at the antenna. Up is transmit power. This is the frequency display, and this chart is how to use the radio. So if we turn on, so if we push that down, we're getting almost about 120 watts on 10 meters. Manual. You can see the sideband works. November 8 Zulu Radio Yankee. November 8 Zulu Radio Yankee. The switch band, you push this in, rotate the tuning knob so that the dot is on the very first digit. That's the band switch. Rotate it, and it digitally selects next band automatically, and it rearranges all the filters accordingly. So on CW we get about, on 6 meters we get about 60 watts out. November 8 Zulu Radio Yankee. November 8 Zulu Radio Yankee. So if we take the back cover off, pops out like that. So you can see there's a speaker. Here's the power amp. Here is the power supply. This is a switch mode power supply, 28 volts, 10 amps. Here's the driver and pre-driver chassis. This is the TR switch and bandpass filter assembly. And over here you can see the front panel controls. There's their signal meter, AF gain, TX gain, RF gain, or rather AGC sets, and then the switch between the modes. Let's flip it over, show you the inside. Alright, here's the inside of the radio. So, what we have here is we've got the RF front end board with the two bandpass filters. Actually, sorry, this is the front end mixer with the two bandpass filters, third order. This is the LO amplified signal chain here. Underneath this board is the front end board. This is the BFO. That's the IF with two crystal filters for single sideband and one for CW. Here's the AGC board. So a lot of stuff going on there. This also takes care of the transmit delay in CW. We see a couple of the voltage regulators. There's voltage management devices all over the place in this radio. Right up here is actually the VFO, which is a little PLL board made by an outfit in Texas, I believe. It's very tiny and it fits right up in there. So this is the back side of the radio. Let me bring it back down so you can see. Front. All right. So there, of course, will be a bottom cover bolted on as well. But this is it. This is my Homebrew Challenge radio. It's now complete. The next step is we're going to try it out on the air, make sure everything works there. Okay, now we're going to check the transmitter spurs. I've been spending a considerable amount of time getting the transmit spurs down to a reasonable level. On 6 meters, they need to be 60 dB below the carrier, and on HF, I think it's 40 some odd dB. So we've got it all tuned up now. So I'm going to hit the CW carrier oscillator, and we'll show you what the output looks like for 6 meters. Alright, so spurs emissions are down to exactly minus 60 dB or lower, and the transmit output power is 100 watts. Now changing bands over to 10. Okay, now we're down to 10 meters. Let's hit the CW carrier oscillator again. There are the spurs in 10 meters. They're down below minus 50 dB below the carrier. And output power is 130 or so watts. So the next step is to put in a VISWAR protection circuit, because this is a very high power radio. We'll have to protect the MOSFET power amp. Here's a look at the MOSFET power amp as it is right now. It's really stable design, very happy with it so far. I'm going to demonstrate the VISWAR protection system on this radio. We have a BLF 647 150 watt transistor right there, and it must be protected against open circuit or short circuit VISWAR. So here's the board. You have the LM339 comparator and HCF 44BE flip-flop. We have a MOSFET there that shorts the bias of the power transistor, and this transistor is for the alarm. So right now we've got our 50 ohm dummy load power meter hooked up. So if I key down the tune switch, you'll see 100 watts. And now let's unhook the dummy load. See what happens. As you can see, the LED's on, a loud buzzer, and we key the radio, no power coming out. The alarm isn't reset till you cycle the power on the radio. Okay, so I finally buttoned up the default logic, the VISWAR alarm unit here. So this board here, this little daughter board, what it does, it protects that transistor from high VISWAR. As you can see right there is a VISWAR bridge, and the forward reflected power fed into this comparator. This potentiometer sets the maximum reflected VISWAR. It's nice because it's always proportional to how much power we're transmitting. Here's a latch that will engage as soon as this trips. And the latch will bias this MOSFET here, which will short out the bias supply over here to the transistor, therefore shutting off. The second MOSFET, what it does, it turns on this buzzer so that you can hear the front of the panel of the radio, you can hear that it's a fault, and there's an LED for convenience for troubleshooting. So these MOSFETs are a little big, but they could have been the 2N7000, but I've I don't have any of those laying around, so I have a lot of these that are surplus from some other stuff that I've worked on, so I just decided to use them. Alright, so we'll do a little demo here. Right now we've got the 100 watt PA hooked up to the dummy load power amp. So you can see we key down over 100 watts out. Everything is happy over here. Now what we will do is we will unhook the transmitter. So open circuit right from the PA, and we'll hit the transfer button. And as you can see, we hold the transfer button down, no power coming out.